Right? 10 times 10 times 10 equals 1,000. 10 squared, what's that? 100. What's 10 to the exponent 0? 1. 10. So you guys see the pattern? What's happening to the zeros? Decreasing. So technically what it is, I'm moving my decimal place over 1. Okay? So then what would be the next answer? 1. Not 0, right? Follow the pattern. Now if we follow the pattern further, what's 10 to the exponent negative 1 equal? No. Yeah, you move your decimal one more place over and equals no negatives at all. It equals 0.1. All you move is your decimal place over 1, over 1, over 1. Okay, turn it off. Okay. So what is 10 to the negative 2? Next time it rings, you're going to have to get up and dance for the class. I think that would be quite entertaining. Okay. 10 to the negative 2 then, what will that equal?
0.2.
No. Follow the pattern. Move your decimal place over 1 more. 0.01. Okay. Do we have a negative result from negative exponents? No. That's very important. Do negative exponents give you negative answers? No. We're going to come back to that in a second and talk more about that. But let's go to the other method for showing the power value of 1. So if we write this out the long way, we can, the value of 0, pardon me. Showing our work, it'd be 5 exponent 4 minus 4 gives us 5 exponent 0. But what does that really equal? Yeah, you're all saying 1, but why? Let's write it out the long way. Now when we cancel these out, they don't cancel to nothing, they cancel to 1. These all are just canceling to 1. We're dividing by 5 each time and reducing our fraction. So technically we have 1 times 1 times 1 times 1 times 1. On the bottom we have the same thing. So really when you multiply the tops you get 1. What happens when you multiply your denominators? You get 1. And so now what's 1 divided by 1? 1. Okay. So that's another way of showing that the exponent 0, which is what we got by using our rule, gives us the value of 1. Okay. So never ever leave an exponent with a power with the exponent 0. Never ever. Instead, what do you have to do? Write the value of 1. Okay. So you're going to be working along, doing all the same stuff we just did yesterday, and you'll get 16 to the exponent 0. That doesn't equal 16. What does it equal? 1. Perfect. So let's try these right here. For A, please simplify it. So give me an answer on the top and on the bottom. Then tell me what the exponent equals, and then the final value. Okay, so the first step is just to simplify that, please. By showing your work now, all you need to do is to change your exponent to what it should be. Okay, 20 to the exponent what? Brianna, what do you think? Multiplying the 20s, what do we get? What should our exponent be? Good. On the bottom, we have 20 exponent 10. So when you divide them, what do you get? 20 exponent, 20 exponent, 20 exponent, 20 exponent, 0. Which has a value of what? Make sure you show all your steps. Okay. Okay. B. What's the value of B? We have these letters as our base. What's the exponent for that base I underlined? Stephen? 0. Exactly. So what do we have then? even though we have letters, we know the value. It must be 1. Okay, now we have a word. Wow, isn't that cool? We have a word. Now you know the real meaning of a word. What is it? 1. Okay? Because it's inside the brackets, it all has a value of 1. Okay, try D. So you'd get 1 plus 25, which equals 26. Are you guys ready for the real tester? Oh, I love this one. This is my favorite. 4 exponent x to the power of 0 plus 4x 0 minus negative 20 to the exponent 0. Tell me what the value is. So what you need to do is rewrite the changes below, please. That's how we show our work, by rewriting the changes below. Okay, so fill in the red blanks. And then tell me the final answer. Okay, who's the final answer? Be brave. Come on, take a chance. Michaela? Tisa? 28? Okay. Anyone else? Be brave. His answer's not right, so there must be another one out there. Eliana? Yep. 2? Okay. You can go home. 1? Okay, Eliana got 1. Yep. 1. Yep. 3. Okay,
Pardon this interruption. Photographers are now ready for grade 10s who need retakes or who missed the original photo day. Thank you.
So, gotta focus on what's your base. Here's our base. That means everything inside the brackets has the exponent 0 applied to it. That means the entire thing equals 1. Here we have a 4, which has absolutely no exponent on it. So it stays as a 4. You multiply it by the x, and what's the value of the x with the exponent 0? 1. There's your trick. Tricky, tricky. Okay, and then minus sign, what's negative 20 to the exponent 0? 1. Everything inside your brackets must be 1. So then we simply go 4. What's 4 times 1? This would be 4. So 1 plus 4 is 5, minus 1 gives us 4 as our answer. Okay. Here, I'll give you a bit of an easier one. Try this one. Here's example F. Negative 3, the exponent 0, plus 12 exponent 0. What does that one equal? Hands up if you think it's 2. Oh, come on. I know people think it's 2. My hand's up. Okay. Why isn't it 2? Yeah. Yeah. Here, F, this negative sign has nothing to do with the base of 3. Nothing to do. It's your coefficient. So that stays. But the 3 becomes a 1 because of the exponent 0. The 0 does not apply to the negative sign. There's no brackets. Plus 1. And so when you add them together, then you get 0. Okay, so yeah, think about it. All right. So today, negative bases, you're going to see that. Bases can never write, right here, never ever write an answer with brackets. Okay, so from now on, no more brackets. Okay. If the power is negative, so it's an odd exponent, it's all right. So let's have a look here. Expand. Negative 12 5 times. Negative 12 times negative 12 times negative 12 times negative 12 times negative 12. Now all we're going to focus on is our negative signs. These two will multiply and get a positive number. These two will multiply and get a positive number. But then you have a negative number at the very end. So what are you going to get as a final value, positive or negative? Negative. Okay. So that's because it's an odd exponent. But here, let's combine these together using our rules. Negative 5 to the exponent what?
11.
Oh, this should change. Change this to a 3. Oh, actually, no. If you keep it as 11, haha, sorry. I was confusing my questions. Keep it as 11. And so what's our final answer then? Is it positive 5 to 11 or negative 5 to 11?
Negative 5.
Negative 5 to 11. Never brackets in your final answer. Okay, so the last step is always deciding on what to do with your negative sign. Do not do that sooner. I didn't even talk about it here or here. I looked at it right at the very end. Okay? So, here, if the value of the power is positive, then you should have, it's when you have even exponent. So right here we have negative 12 to the exponent 6. What would we write as our final answer? Positive 12 exponent 6. Okay? So when we drop our brackets, we know because we have an even exponent, our final answer must be positive. Okay. So don't start looking at it here. You want to simplify it first. What should be the exponent? 4. And so then how would you write your final answer? This is a 2-step question, by the way, folks. 2 steps. That's what I'm looking to see. Vanessa? Good. Positive 7 exponent 4. Okay. Good. Any questions? All right. So here's your rules summarized right here. This is your gold. Don't lose your gold. Okay. If the base is odd, negative base and it's odd, you keep your negative sign. But if it's even, it becomes a positive. Okay. Okay, turn it over. So this is just the pattern. Okay. 2 rules for negative exponents. Never ever write a final answer with a negative exponent. And rule number 2, never write a decimal answer, because I know you just cheated on your calculator. Okay. So a logical thought process, we talked about this from the front, 1,000, 100, 10, 1, and then we keep moving our decimal place. Okay. So we just been moving our decimal place. So for 10 to the negative 1, we should get 0.1. And then what should we get for 10 to the negative 2? 0.01. Move to the next one. Good. Do we have any negative values? No. But what rule did I just break? Right there. Never write a decimal answer. So what do we have to do? Yeah, let's turn those into fractions. That's 1/10. What's the next one? 1 over 100. 1 over 1,000. Okay. Now that's a lot of work. In fact, that's too much work. What we want to do now is write the bottom. Can we simplify the bottom using exponents somehow? What would this equal? 10 to the exponent what equals 10? 10 to the exponent 1. What would the next one be? 1 over 10 squared. Oh, it almost looks like we have a pattern. What would be the next one? 10 cubed. So, This step is what we should not be doing, because what's easier? We take our negative exponent, and how do we make it positive? By writing in the bottom of a fraction. That's some pretty cool stuff. You guys never seen that before. How do we make this -3 positive? By writing it in the bottom of a fraction. Okay. So let's play around with this a little bit. To solve these questions then with our negative exponents, we flip the power over the fraction line, a over b, and then the exponent's positive. Okay. So the negative exponents equals what? Negative exponents, they don't give us negative numbers, they give us fractions. Fraction, fraction, fraction. Oh, fraction. Okay. So the first step is to make your exponent positive, just like this example with our 3, -2. But now we can figure out what the value of that is. So the 1 doesn't change. Well, what is the value of 3 squared? 9. And that's our answer. Okay, next one. 1 over -8/7. So now it's a little bit different. Where's the negative exponent? It's in the denominator. So now what we have to do is really we flipped it on top of the 1. But we just never write that. It's just really weird, isn't it? Right? Okay, so then we can use your calculator. You should grab yours out, please. $2097152. So if we're in a fraction, we got to take it out of the fraction. Oh, this one is a great example. What should we do here? The negative sign is on the outside of the fraction. So for this example, everything on the inside gets flipped. And now our exponent becomes +4. Pretty cool. It's a flip and fraction rule. All right. So how do we bring that 4 inside? Drop your brackets now. Go. Apply your exponent rules. Get rid of your brackets. Be very careful now. What's the exponent on the 5? 4. And the exponent on the 4 on the bottom? 4. Now I just want to show your work so you're not forgetting. Technically what we're doing is we're multiplying in by our hidden 1 exponents. It's not magically happening, folks. It's a multiplication process. Okay. Now you can evaluate the top of the fraction and the bottom. Go ahead. Okay, and so that's our final answer. I don't believe we can reduce that. Okay. Any questions? Okay. A couple more examples then. So for this next one, we're not simplified yet. What is the new exponent? 2 exponent what? What should be our exponent? Yeah. 1 plus -3 is the exponents. So what should we get? -2. Okay. Now fix that. So take your exponent and make it positive by flipping it over the fraction line. Go. So we get 1 over 2 to the positive 2. And what does that equal? 1 over 4. So there's your final answer. So you have to do 1, 2, 3 steps to get where you need to be. Okay, so you need to show your work and think about the logic involved. Okay. Try this next one. 3 plus 4 to the negative 2. So you need to fix this first. Go ahead. So it becomes 3 plus 1 over 16. So, whoops, sorry, jumped the gun there. 4 squared. Okay. 3 plus 1 over 16, which is 3 and 1/16. Right? So much better. Okay. Think you guys can handle negative exponents? So I have a worksheet for the negative exponents. We're going to get on that in a second. What you need to do, first of all, is start your textbook work.